something grabs you. Not fast and violently, just a quiet, deliberate pressure wrapping around your leg, then your waist. And then, before your brain has registered what's happening, you can no longer fill your lungs. This is not a bite or a venom. This is something older, something far more patient than anything built on speed. This is a green anaconda. And from the moment it has you, the physics of your own body begin working against you. And here's why you can't escape. The green anaconda is the heaviest snake on Earth. The largest confirmed specimens reach lengths of over 6 meters and weigh close to 100 kilograms. That is not a long, thin rope. That is a dense, muscular column of tissue shaped over millions of years into a single purpose: restraint. To understand why escape is almost impossible, you first have to understand how the anaconda actually kills, because the common assumption is wrong. Most people believe constriction means crushing. It doesn't. For decades, scientists themselves believed anacondas killed by compressing the ribcage until the prey suffocated. That model has since been revised. Research published in the Journal of Experimental Biology revealed that constriction's primary mechanism is circulatory. The anaconda applies targeted pressure to specific points along the body, collapsing blood vessels and stopping blood from reaching the brain. Death from circulatory failure arrives faster than death from suffocation. In documented prey animals, cardiac arrest occurred in under a minute. This distinction matters enormously, because it means the anaconda does not need to squeeze with maximum force. It needs to squeeze with precision, and it is extraordinarily good at exactly that. The body of an anaconda is not a single muscle. It is a system. Beneath the scales, hundreds of independent muscle groups run along the spine. Each can contract and release independently. Each can adjust pressure, angle, and direction in real time. This means the anaconda can feel what you are doing and respond to it. If you push outward against the coil tightens just enough to absorb that force and redistribute it. If you try to unwind it from one direction, adjacent coils shift to compensate. The entire body functions as a living adaptive mechanism that reads your movement and neutralizes it. This is not instinct in the way we usually think about instinct. It is a biomechanical feedback system refined across tens of millions of years. The anaconda does not consciously decide to tighten when you struggle. It simply does, because that is what constriction-adapted muscle architecture does. The response is built into the tissue itself. And the strength involved is significant. Studies on large constrictors have recorded pressures exceeding 300 millibars of force applied around the thorax of prey animals. For context, that is roughly equivalent to a person having 2 full-grown adults sitting on their chest simultaneously, without release. But raw strength only begins to explain why escape is so unlikely. There is also the environment. The anaconda does not hunt in open fields or on dry ground. It hunts in the vazia, the seasonally flooded forests of the Amazon that submerge for months each year. The water there is brown, near opaque, dense with suspended sediment. Visibility at depth is effectively zero. In this environment, the anaconda holds every advantage. It is semi-aquatic by anatomy. It can remain submerged for over 10 minutes, moves through water with almost no detectable surface disturbance. In water, your movement slows. Your ability to plant your feet and generate leverage disappears. The fixed points you would need to push against to unwrap a coil from your body simply don't exist. You cannot brace or find purchase. The water that the anaconda is built to inhabit becomes the same medium that removes your ability to resist. The anaconda understands this. It waits in the shallows with its body already coiled below the surface. It strikes low, targeting the legs or lower torso, then immediately pulls the prey into deeper water. The first seconds of contact are everything. In those seconds, if you cannot free yourself before the full coil sets, the probability of escape drops to near zero. Not because the anaconda is trying harder, but because your options run out. There is another factor that almost never gets discussed: time. The anaconda is not in a hurry. When it holds prey, it is not exerting maximum effort continuously. It holds, maintains pressure, and waits. Every movement you make to escape consumes oxygen and energy you cannot recover in that moment. The anaconda expends almost nothing by comparison. Its resting metabolic rate is among the lowest of any vertebrate of its size. It can hold a coil under moderate sustained tension at minimal physiological cost. In documented encounters between humans and large constrictors in the wild, this dynamic appears consistently. The individuals most at risk are not necessarily the weakest. They are the ones who exhaust themselves early, before a second person can intervene, before the coil can be addressed at its source. So what would actually help? The biology offers one narrow and uncomfortable answer. The anaconda tracks prey primarily through vibration and heat. Infrared-sensitive labial pits along its jaw detect the thermal signature of living tissue. When prey stops moving entirely and body temperature begins to drop, the stimuli that drive continued constriction weaken. This is not a reliable escape strategy. It is a physiological opening, a brief window before oxygen deprivation forecloses every other option. The more practical answer is also the most honest one: prevention. Anacondas are ambush predators. They don't chase or stalk across open ground. The attack begins at the moment of physical contact, which means the only reliable protection is not entering the zone of contact in the first place. Indigenous communities across the Amazon have understood this for generations. You don't wade into murky water alone or move through flooded forest at low light. You learn to recognize the stillness that exists before a strike. The anaconda has no biological reason to treat a human as prey. An adult human being is too large to swallow whole, and the anaconda knows the size of what it has within seconds of making contact. But an anaconda that feels threatened, cornered, or accidentally encumbered does not make a careful assessment before reacting. The response comes first. The assessment comes after. The anaconda you are most likely to encounter is not the largest. Record-breaking specimens, those pushing past 6 meters, are rare in the way that any extreme outlier is rare. Most anacondas encountered by researchers and local people are smaller individuals, but a 3-meter anaconda still carries coiling strength that most adult humans cannot overcome alone. The same physics apply at reduced scale. The mechanics don't require a giant animal. And the largest anacondas? They remain largely unmeasured. The Amazon covers nearly 7 million square kilometers. Most of it has never been systematically surveyed by scientists. A 2025 study from the Peruvian Amazon followed radio-tagged anacondas with precise GPS coordinates. Even knowing exactly where the animals were, researchers could visually confirm only 17% of recorded locations. The rest of the time, the snakes were completely invisible, beneath root mats, buried under leaf litter on the river floor, pressed into sediment with nothing but the nostrils breaking the surface. In a forest this vast and this opaque, the upper limit of what these animals can reach in size has not been established. Perhaps it has not been reached yet. However, 60 million years ago, there were snakes twice as large as today's. One of them was the Titana boa. Its size was incredible, about 15 meters long and weighing over a ton. She fed on crocodiles. Before swallowing the prey, it would wrap itself around it, breaking the bones and cutting off the blood supply, with a pressure twice that of today's snakes. The titanoboa was so big because the climate was warmer and wetter back then. It is believed that it could swallow today's man without any problems. There is a reason that every culture living along these rivers carries stories of enormous anacondas. Not because the people are superstitious, because the river keeps producing encounters that refuse to be fully explained by the animals we know about. The coils that could hold you don't need to belong to the largest anaconda ever recorded. They just need to close before you realize they are there.